So we're going to work some more on this idea of looking at a graph of f prime and trying to come up with a graph of the f that has that derivative. So in this one, we are going to answer the questions to 49 here, and then we're going to, after that, to number 53, which is going to ask us to graph a continuous function f that has these characteristics. It has this as its derivative. So first we want to know where is this, where's the graph of f increasing and where is it decreasing. So remember, when the derivative is positive, then our original function f is going to be increasing. So f will be increasing on that interval, and we're only defined here from 0 to 6. So this does not extend beyond what we see here. So it's going to be increasing on the interval from 0 to 1, and also from 3 to 4, and again from 5 to 6. So those are the intervals where, or actually probably not 5. That looks maybe more like somewhere in the neighborhood of wherever that crosses there. We'll say 5.5 to 6. And to answer B, where's the function decreasing? That's going to be where the derivative is below the x-axis. So that's going to be from, I guess, from 1 to 3, and also from 4 to that 5.5, I think is what we have called that. And part C says, can we find the x-coordinates of the relative extrema? And so that's going to be where the derivative changes sign. So we can see at right here at 1, the derivative goes from positive to negative. So that's going to be a relative maximum. And then we see at 3 it goes from negative to positive. So at x equals 3 we'll have a relative minimum. And we also see that right here at 4 the derivative goes from positive to negative as well. So that's also going to be a relative maximum. That was at 4. And then we also see that at 5.5 it's going from negative to positive, so also at 5.5 we'll have a relative minimum. Okay, and then we have, what else? Anything else? They asking us concavity? I don't see that question, but let's go ahead and answer it anyway. So we'll say it will be where the function is decreasing, so where the derivative rather is decreasing, our function is going to be concave down, and so that's going to be from 0 to 2, and it's also, I think that's going to be the only places. So then it's going to be concave up, where our function is increasing, our derivative rather is increasing, so that's going to be on those intervals. So we can say from 2 to 4 and also from 4 to 6. Okay. Well, let's see if we can now put this together into a graph. So let me get my pen here. Oops. Okay, so here is going to be our xy axis, and we're told that f of 0 is equal to 2, so this is the only y value we know for sure. The rest of it we're just going to kind of see where we go. So we've got that our function is increasing till we get to 1, and then we're going to have a relative maximum there, and it's also, we said, concave down. So I'm just going to pick the y value there to be above where I was at 0, 2. It's going to be increasing and concave up. Then it's going to decrease and it's going to be concave down until we get to 2. So once we get to 2, decreasing and concave down till we get to 2. Then at 2, we're going to see it's going to change concavity. It's going to continue decreasing until we get to 3. So I'm going to go to 3, something like that. So at 3, we're going to have a relative minimum. Then from 3 to 4, it's going to increase again, and we're still concave up. So I'm going to go increasing concave up till we get to 4. And then once we get to 4, it's going to be decreasing, and it's going to be still concave up. And we're going to decrease until we get to 5.5. So there's 5, and 5.5 is going to be in there. So it's going to decrease, still be concave up until we get to 5.5. And then after 5.5, it's going to be increasing again, and it's going to continue being concave up. So it's going to do something like that. Okay, let's see what else we got. Go to a new page. So now on number 50, we have our domain is going to be, here's our f prime, and we're going to try to graph this as well. So let's see if we can answer those same questions. So first, where is f increasing? And again, that is going to be when our derivative is positive, which is everywhere here. So we're going to be increasing for, I guess, 0 to 3. And we are going to be decreasing never. And let's see if we have any relative extrema. Well, we can see it never changes from positive to negative or negative to positive. So there aren't any relative extrema. And let's see if we can talk about where it's concave up. It's going to be concave up when our derivative is increasing. So that's going to be from 0 to 1. And then it's going to be concave down where it's decreasing, and that's going to be from 1 to 2. Now on this stretch right here where the derivative is constant, that means we're going to have a line that has slope 2, so it's going to look like y equals 2x plus, we don't know what the y-intercept is, but it's going to be a straight line with slope positive 2. Okay. And the problem on the other page, it said that f of 0 is negative 3. So that's the only y value that we know. So let's see if we can put this together in a graph. It's going to start at negative 3. We know it's going to be increasing throughout the interval. It's going to go concave up until we get to 1. So it's going to be increasing and concave up. Then it's going to be concave down until we get to 2. So still increasing, but now concave down. And then after that, it's going to look like a line that has slope 2. So we're going to pick it up from right here. So I'm going to put some tick marks so we can see where we're going to go. So we're going to have to rise 2 and run 1. So that's going to get us a straight line like so. And there's our graph of f of x. Okay, let's slide this up a little bit and see what we've got here. So now we have some information about our function, and its derivatives are given right here and also for here. So these are specific values and these are intervals down here. So let's see if we can find any absolute extrema. Let's wait on that one until we get a little bit more information, maybe even the graph, because we'll come down here and graph it. So inflection points are going to be where the second derivative is 0 or undefined and it changes sign. So it looks like our second derivative is negative all the way through. So I think we can say here anyway, there are no inflection points. So let's see what we do know. So this is going to be, it's a continuous function on the interval from 0 to 3. And we know that f of 0 is 0. Let's get these points down. We know that f of 1 is 2. So we can get that point down. We know that f of 2 is 0. So that's going to be a point on our curve. And we know that f of 3 is negative 2. So this is the points that we know. Now let's see, in between 0 and 1, our derivative is positive. Our function is positive, so it's above the x-axis. Our derivative is positive, so it's increasing. And the second derivative is negative, so it's going to be concave down. So it's going to be increasing, concave down, above the x-axis. In between 1 and 2, the function will still be above the x-axis, but now it's going to decrease and continue to be concave down. So we're going to get something like that. Then we're going to see that between 2 and 3, now we're below the x-axis because the f is negative. It's going to be decreasing because f prime is negative, and it's still going to be concave down because the second derivative is negative. We can see that at 2 that our derivatives do not exist. So since we have a continuous function, that means we're going to need to show some kind of a corner point there. So something maybe like that. So it's decreasing and concave down, but the way that these come together, we have to have different slopes of tangent lines on either side. Okay? All right, let's go on to the next panel and see what we can do with this one. So on this one, we can see that it's an even function. That means it's going to have symmetry in the y-axis, and it's continuous, and we're going from negative 3 to 3. So let's see what we can come up with here. We're going to go from negative 3 to 3. And we know that, let's get our values of the function. F of 0 is 2, so we know that's a point on the curve. F of 1 is 0, so we got a point there. And f of 2 is negative 1, so that's going to be a point there. Now because of the symmetry, then we also know there must be a point at negative 1, 0, and also a point at negative 2, negative 1. Now let's see what we know. The derivative doesn't exist at 0, so we're going to have some kind of corner or cusp, and it's going to be a 0 derivative at 1, and it's not going to exist at 2. So let's see what we know maybe between 0 and 1. Between 0 and 1, it's going to be, the function's above the x-axis, it's going to be decreasing, and it's going to be concave up. So decreasing, concave up is going to look something like that. Because of the symmetry, because it's even, then we get to do the left side kind of simultaneously. In between 1 and 2, it's going to be negative, so it's below the x-axis. The derivative is negative, it's going to decrease, and the second derivative is negative, so it's concave down. So decrease, concave down, something like that. And likewise on the other side, decreasing, concave down. Between 2 and 3, the function stays negative, but that's just up until 3. The derivative is positive, so it's increasing, and it's still concave down. So we can do, and we can make it be equal to 0 here, because this is saying that it's going to be negative all the way up to, but not including 3. So I would do it kind of like so. All right, there we go. Let's see what else we got. So we have another table of values here. So again, we see, let me get a color up here. So it's a continuous curve. And so let's see what we got. I'm going to draw an XY axis here. And we know the y value when x is 2, y is 1. So that's a point that we know is on the curve. When x is 4, we know y is 4. So there's another point we know on the curve. What else do we know? When x is 6, then y is 7. So 1, 2, 3, 4, 5, 6, and we got 4. I didn't plan this very well. 2, 3, 4, 5, 6, 7. We're going to be all the way up here. Okay. Okay, we have for x less than 2, it is falling in concave up. So here's our 2, so it's going to be falling in concave up till we get to there. Then from 2 to 4, it's going to be rising and concave up. That's going to take us up to there. And then from 4 to 6, it's going to be rising but concave down. It's going to take us to there. And then we have a horizontal tangent at 6, 7. So a horizontal tangent, well, we could do a couple of things here because we really don't know what's going to happen to the right of 6. So kind of a natural choice, I think. I'm going to give you a couple of options here. It looks like it could continue down this way. But there's really nothing to indicate that we couldn't have like a shelf point and then go on up this way as well. So I think either of those options would fit the limited information that we were given. All right, very good.